This video is naming organic compounds with functional groups part 4, the nomenclature of alkenes and alkynes. Thus far we've discussed IUPAC nomenclature only in terms of alkanes, or single bonded carbon chains and rings of various sizes. When we look at an alkane, we say that it is saturated with hydrogen. This means every available bond that carbon does not make with another carbon or a functional group is occupied by a hydrogen. Alkanes are saturated hydrocarbons. Alkenes and alkynes, however, are unsaturated hydrocarbons. They're hydrocarbons that contain one double bond or one triple bond between carbons, respectively. Alkenes are named the same way as alkanes, except the ending of the compound is ene, ene, instead of ane, ane, and the double bond is considered a functional group of the alkene. The double bond is always included in the longest chain possible. It is also assigned the lowest possible number unless another higher priority suffix-changing functional group is present. Other than these rules, alkenes are named using the same rules as alkanes. Alkynes are named in the same way as alkanes and alkenes, except instead of ene for alkenes or ane for alkanes as the suffix, yne becomes the suffix. Alkyne. Yne, ein. Other than that, the rules are the same. So let's take a look at an alkene. Here's our first alkene, and I decided to be a little bit tricky, and I included a hydroxyl group. Recall, this hydroxyl group makes this actually an alcohol as well as an alkene. So I'm going to show you how to name something with multiple high priority substituents. Now, we count the carbons from this end, and we see that there are double bonds at 2, 6, and a methyl at 6, and an alcohol or hydroxyl group at 8. When we number this way, we see we have an alcohol or hydroxyl group at 2, double bond at 3, methyl at 4, and double bond at 7. Let's compare these number lists. So 2, 3, 4, and 7 is lower. However, according to IUPAC nomenclature, we have to give the highest priority group the lowest number possible on the parent hydrocarbon chain, which as we see here is 9 carbons. Therefore, I've underlined the double bonds and circled the number positions of the hydroxyl groups. OH groups are higher priority, so we will give them the lowest number. Now in this case, 2, 3, 4, and 7 is lower than 2, 6, 6, and 8, and therefore the high priority low numbering system did not conflict with the way we've numbered things in the past. But in our alkyne example, it will. So we're going to go with the numbering 2, 3, 4, and 7. But we have another interesting situation here. The alkene suffix is ene, ene, and there are 9 carbons, so this will be nonene. However, alcohol suffix also has to be applied, which is an ol. How are we to number where the double bonds are and where the alcohol is if we keep nonenol one word? The answer is we can't. We split the last name of this hydrocarbon chain, nonenol, with the number going with the alcohol by the ol suffix and the number going for the ene in front of nonen. Don't forget the methyl group at 4 as a prefix, and now we get 4 methyl, 3 7, nonen 2 ol. Now let's label an alkyne. Numbered this way, the alkyne gives us substituents at 2, 5, and 5. Numbered this way, the alkyne gives us substituents at 3, 4, and 7, with a total of 8 carbons. However, these are methyl groups, and the triple bond gets priority over the methyl group in numbering. So we have to try and give the triple bond the lowest possible number. This means, unlike previously, we're going to choose the numbering 3, 4, 7 direction, and we're going to name this molecule 4,7-methyl 3-octine.